Alright guys, so we're taking a look at Learning Target 2.1, Solving Equations Practice. So we've got a bunch of equations, we're just taking a look at how to solve them. So we've got a few where we're just looking at somebody that did some, and we're just trying to find the mistake, okay? So if we look at the first one, we have 10 minus 2x equals 6. So they added 10 to both sides. So if I have a positive 10 and I add 10 to it, is that going to become 0? It isn't. It's going to become 20. So there's their mistake, right? They did not subtract 10, which is what we should have done. Instead, they added 10 to both sides. So there's our mistake. What should they have done? They should have subtracted 10 to each side, right? Because then we would have got negative. The second issue I guess they did is they didn't bring down that negative either, did they? So we should have subtracted 10 from both sides. 6 minus 10 would have given us a negative 4. Okay. Then instead of dividing by negative 2, they subtracted negative 2. Okay, so this guy, they actually made a ton of mistakes. Pretty much every mistake you can make, they made. Okay, so we needed to divide by a negative 2, and then that would have given us a positive 2 as your answer. Okay, so subtract a 10 to each side is what they needed to do. Then bring the negative with 2x and divide by negative 2. Okay, number 2. They got 3x minus 10 equals 57. They subtracted 57. Now this is a mistake I see a lot. Okay, everything else they did fine, but they were subtracting from here. What would happen is we'd have 3x minus 67 equals 0. See, and then somehow their equal sign switched hands. Okay, now, had they went plus 67 to both sides and got 3x equals positive 67, that would have been fine. Okay? So what they didn't do is they subtracted the wrong number. So you need to add, in this case because it's negative 10, add 10 to both sides. Okay? So if we would have added 10 to both sides, we would have got positive 67 equals 3x, divide by 3, and you would have got a positive 22.3 repeated. Alright? Okay, number 3. So 2 times 4x minus 10 equals 14. So we need to distribute, right? 2 times 4 is 8. 2 times negative 10 should have been negative 20. So there's their mistake, isn't it? Okay. Everything else looks good, so they messed up on distribution, so need to distribute to both numbers. So then we would have added 20, right? Giving us 34, not 24. Then dividing by 8 would have given us 4. Let's see, that would be 4. 4 times 8 is 32, and 2 8s should be 4 1/4, or 4.25. Okay? So that's how we would have fixed that one. Now, number 4. They started by subtracting by 2. Okay, now remember, when we deal with order of operations, okay, we're doing it backwards. So had we known what x was, we would add 2, then divide by 3, which means we need to get rid of this 3 first by multiplication. So they did the wrong order. We would times by 3 first, then subtract 2. Okay, so by multiplying by 3, you'd cancel those out. And we'd get x plus 2 equals 30, because 10 times 3 is 30. Then we subtract 2, we get x equals 28. Okay? Alright, now the rest just wants us to solve each equation. Now we're starting out with some simple ones, okay? And the whole idea when we solve an equation, okay, the thing you're thinking about is kind of, the first step is to recognize what is happening to x. Second step would be to simplify as much as possible. third step would be, and this is super general, would be to get the variable alone on one side and number alone on the other. Okay, and to do that, we're doing those inverse operations to undo things, and we're doing them in reverse order. Okay, that's kind of the idea here. So if we look at number 5, we can say, okay, what's happening to x? Or I guess I should just say variable, not x, so we use x a lot. V minus 8. That is what's happening, is v minus 8. So we need to simplify. We can't really simplify that any further. So now we get the variable alone. So we want to get rid of that negative 8. So how do we do that? Well, we add 8. Because if we add 8 to negative 8, it becomes 0. And we're just left with v. But because we're dealing with equations and we're making equivalent equations, okay, right? Because we're making equivalent equations, equations that still work the same. So we need to do it to both sides, and those properties of equality tell us that that's how we need to do it. So 3 plus 8 would be 11. We get v equals 11. Okay, if we look at, now I'm going to have to erase all that, huh? If we look at number 6, we've got a plus 18. So we recognize that we're adding 18 to a. So to undo that, we need to do the inverse operation, which would be subtracting by 18. So we subtract 18, and we do it to one side. We have to do it to the other side. That becomes 0, which adding 0 does nothing, so we're left with a. 38 minus 18 gives us 20. Okay, number 7. Now this one has a fraction, which freaks a lot of us out, but that's okay. It's just a fraction, don't worry. So it's really r divided by 19, okay, because that's what that fraction bar means. It means divide. So if we're dividing by 19, we need to do the opposite, and we need to multiply by 19. Again, if we do it to one side, we've got to do it to the other side. So we go, and really what's happening here, just so we understand a little bit better, is that really we're going 19 over 1. So we'd go r times 19 to get 19r, 19 times 1 to get 19. So that's really like 19 over 19 times r. So 19 over 19 becomes 1. 1 times r is just r. But most of the time we say that just eliminates, but it becomes 1, leaving us with just an r. And then 19 times 9 ends up being 171. Okay. Now if we look at number 8, when we have a number squished with a variable, okay, that number's like an amount, okay, and it always means multiplication, okay. So I want to do the opposite of multiplication, the inverse, which would be dividing. So I divide by negative 16. Again, that becomes 1, and we eliminate the 1 because multiplying by 1 does nothing, and we end up with 80 divided by negative 16, which becomes a negative 5. Now, these are all super basic, simple equations. Now for these two-step, so the two-step means they have two pieces. It's like they've taken one of these situations and then they've combined it with another. So in this case, we've got a plus 10. Well, what did we do when we had a plus? We subtracted. But now we've added to it a 7a, a multiply, so it's like we're taking problem number 6 and 8 and putting them together. So we're going to have to chain how we do that. And when we do that, we always use SADMEP. Okay, so we deal with things backwards. So I deal with my subtraction and addition before going to multiplication and division, which makes sense because if I look at what's happening to a here, first, if I knew what a was, I would times by 7. Then we would add 10 to get 24. But when I'm solving, we go in reverse order and we do it backwards, the inverse. So I'd subtract by 10 first, giving me 7a equals 7a plus 0, but 0 doesn't matter, equals 24 minus 10, which is 14. Then, instead of timesing by 7, I divide by 7. So I divide both sides by 7, giving me a equals 2. So my answer is a equals 2. Okay, so on these simpler problems, it can be a good idea to kind of do this trick, okay, where we're dealing with both of these things. So number 10, first I'm going 4 times k, so I'm timesing by k by 4. Then I'm subtracting 5. So going in reverse order, we would add 5, then divide by 4. So I add 5, can't add 5 to 4k because it's a k, and I get 28 equals 4k. Then I divide by 4, giving me 7 equals k. And there's my answer. Okay? So again, 2 times v, so I'm timesing by 2 first, then I'm adding a negative 1, which is really like subtracting a 1. So I do the reverse. I'm subtracting a negative 1, which is really just adding a 1, and dividing by 2. So I add 1, because that makes it 0, and I get 2v equals 14. Divide by 2, because that makes it 1, which we can just get rid of it, and 14 divided by 2 gives me 7. Okay? So it's 12. 7 equals negative 3 plus 2x. What's happening to x? Well, we're times by 2 first, then subtracting by 3. So we need to add 3, then divide by 2. So add 3 to both sides, giving me 10 equals 2x. Divide by 2, and we get 5 equals x. Now, this is really 0 plus 2x, but adding 0 does nothing, so we drop it. This is really 1 times x, but timesing by 1 does nothing, so we drop it. Okay, you've got to remember that, because as we get more complex, we need to know that information. Okay, so the rest of these, we can still treat them the same way. What's happening to x here? Well, we're dividing by 2, then we'd subtract 10. So I need to add 10 first, then times by 2. So I add 10 to get rid of that 10. I end up with positive 9, because negative 1 plus 10, x over 2. Now I times by 2. That undoes that, making it 1, which we just drop, and I get x equals 18. Okay, so I like doing it this way because I think it's just super useful. Okay, number 16, what's happening to x? Divide by 12, subtract 1. I need to add 1 times by 12. So we would add 1 to both sides, giving us x over 12 equals 1 times by 12. And we get x equals 12. Okay. Looking at 14, same idea. What's happening to n? First we'd divide by 3, then we'd subtract 3. So we need to add 3 times by 3. So I add 3 to both sides, giving us negative 6 plus 3 is a negative 3 equals n over 3, because that became 0. Times by 3, making that 1. Times by 3, making that negative 9. So negative 9 equals n. Now, if you want to, you can change that to n equals negative 9. Same thing. Okay, 15, we've got v. So first we divided by 5. Then we subtract 8. Going backwards, we would add 8. And then times by 5. So you've got to have a basic understanding of what all these pieces mean so that you can figure out what you need to do to get your answer. Okay? Now, when we start getting them more complex, like these next ones, it's kind of hard to do that same setup. Okay? But you still could. Now, on 17, 18, 19, and 20, there's 2 different ways we could do this, and I'm going to show you both ways. Okay? One way is just by division first. Okay, so in this case, we'd say, let's look at b. B's in parentheses, so first we're adding a negative 4, or just subtracting 4. Then we're timesing by 4. So for me, I would divide by 4, then I would add 4. So I divide by 4 on both sides, giving me negative 9 equals, that becomes 1, negative 4 plus b. Then I add 4, right? Giving us negative 5 equals b. Okay, same with 19. I could do that same thing. What's happening to m? Because it's inside the parentheses, we'd say we were adding 8 first, then we were timesing by 8. Going backwards, divide by 8, then subtract 8. That's weird that they're the same exact numbers on both of these. That doesn't always happen. So negative 9, again, equals m plus 8, because that became 1. Subtract by 8. Negative 17 equals m. Now, another way we can do it is to use distribution, okay? That's when we take this number out here and we multiply by both inside of it, okay? So if I'm doing this, the idea here that I'm doing first is I needed to simplify by using distribution, right? So 5 times negative 4 is negative 20, plus 5 times x is 5x, equals negative 25. Now I can say what's happening to x. Well, first I'd times by 5, then I would subtract 20. So going backwards, I add 20 first, giving us 5x equals negative 5. Then I divide by 5, giving us x equals negative 1. Okay? So that idea that I had to simplify, I don't really undo this simplification, but that's kind of how you have to treat those as they get more difficult using this method. This method is really good for just understanding the more simple problems in order to figure that out, okay? So, number 20 again, if we use distribution, okay, so I'm simplifying with distribution. 6 times 8 is 48, plus 6 times x is 6x equals 84. So first I'd times by 6, then add 48. So for me, we subtract 48 first, right? Giving us 6x equals, be 6, 36. Then we would divide by 6, giving us x equals 6 for our answer. So either one works. I don't care which one you do first. That's up to you, okay? Now, for these next ones, it's kind of the same way. Now, technically, there are 2 ways to do this one as well, but you don't want to do it the second way, and I'll show you why. Okay, you probably want to do it this way and say, okay, this is like it's in a parentheses, so first, to find b, if we knew what b was, we would add 9, then we'd divide by 2 once we knew what the top was. So first, I'm going to times by 2, then subtract 9. So I times both sides by 2. This becomes 1, which we can just eliminate. 4 times 2 is 8. Subtract by 9. Okay? And we get b equals negative 1. Again, what's happening to x? First, we're subtracting 10. Then we're dividing by 2. Going backwards and doing the reverse. Inverse operation, I times by 2 first, giving us 4 equals x minus 10, because that becomes 1. Timesing by 1 doesn't do anything. Then we add 10 to both sides, giving us 14 equals x. Okay? So this way is probably the easier way to think through these kind of problems. Okay? Because they can be a bit tricky. That becomes 1. We subtract by 6. 15 minus 6 gives us 9. Okay, so what I could actually do is separate this, kind of like we did distribution. It's kind of like we're doing distribution for division, because both division problems are the same, or together. That's like 8/3 plus n/3 equals 4. So I could, if I really wanted to, I would not advise doing it this way. Oh, it's n, not x. I could say I simplified with a kind of distribution concept, and then we would divide by 3. If we knew what n was, then we'd add 8/3. So what I need to do is subtract 8/3 and then times by 3. Now, subtracting 8/3 from 4 is not going to be very fun, and this is why I don't like this. Okay, so 4. If I times 4 by 3, that would be 12. So 4 would actually be 12/3, wouldn't it? 12 minus 8 would then give us 4/3 equals n over 3. Then I would times by 3. Times by 3, that becomes 1, giving me n. Times by 3, that becomes 4, giving me, well, 3 times divided by 3 becomes that, and I get 4 equals n. Which, if we did it the other way, timesing by 3 first, which is this way, it would be 8 plus n equals 12 minus 8. We get 4 equals n. So it works both ways. I just think this way is a lot better. Okay? All right, now, again, we've got some things going on here. Okay, again, I could still try to use this method and say what's happening to n. Well, we'd subtract 2, we would add 1. So going backwards, we would subtract 1 from both sides. And we'd add 2. Where we could also think of it in terms of, well, 1 and negative 2 can be combined, giving us n minus 1, because 1 minus 2 is negative 1. Then I would just add 1 to get 2 equals n. Okay, so it kind of depends. The more complex, you're really kind of just simplifying here. Okay, so I would, if I'm using this, I would simplify first. 7 minus 5, they're like terms, so it would become plus 2. And then I would say I'm timesing by 4, then adding 2. So subtract 2. And then divide by 4. Giving us negative 6. Okay, so they can still kind of work that same way, but you don't have to do it this way. Okay, you definitely don't have to do it this way. So this would be a positive 1. 2n plus 1 equals negative 15. Subtract 1. We get 2n equals negative 16. Divide by 2. N equals negative 8. Okay, so you don't have to do that method that I described. It's there just to help you. Okay, but like I said, sometimes it doesn't help you as much. And feel free to split things up like this and deal with those pieces separately. Okay, there is nothing wrong with doing it that way. Okay, nothing wrong, same way as doing it this way if you combine. And often it's not like it adds a whole lot more to your problem. Okay? But now the problem is we get to some of these where they have variables on both sides, and that's where it gets hard. That's really where my easy method falls short, because how do I decide what's happening to x here, right? Because something's happening to x on both sides, I would need to simplify first. And to do that, I would need to combine the x's. So a 5x and a 7x, I could subtract a 5x to make that 0. And I would have to do it to the same side. So 7 minus 5 would give me 2x. Then I could say times by 2, subtract 6. Okay? So we add 6. Then divide by 2. So it really only works when you only have a variable on one side of the equation. Okay, that's really the only time it works. So if it worked for you, that's great. If not, if you didn't need it, that's great too. But yeah, it only works for these simpler ones. So for these other ones, the idea here is, again, you need to understand what's happening. So I know I've got a negative 6k and a negative 3k. I know I want to get them on the same side. Now, it doesn't matter which side I get them on, okay? That's something you need to understand. It doesn't matter. So I could add a 6k. I could have added a 3k and went to the left. It really doesn't matter which way you go. And you could have even dealt with the 8 and the negative 1 first, or putting them over to the negative 14. There's so many different options. Personally, I like to deal with my variables first. So that becomes 0. 8 minus 1 sticks because that minus stays with the 1. Negative 14. Negative 3 plus 6 would be a positive 3k, because negative 3 plus 6 is positive 3. Now that my k is on this side, I know that my numbers now need to get on that side. And 8 minus 1, I can simplify that to 7. Then I can add a 14. Give me 21 equals 3k, divide by 3, and k equals 7. Okay? Okay, yeah. So that's kind of what you're thinking about on these more difficult problems. Again, you're looking at getting my variables together. Here I'd subtract 1m, because 3m, remember, 3m really means m plus m plus m. Then minus an m means we cut it down to 2m. And then we can simplify it further and get our answer, okay? And it's just like that. So now here, we can simplify these k's first. 4k minus k would be 3k. We didn't touch the -5 or the +5. Then I could add a 7k to both sides, giving us 10k here. -5 plus 10k equals 5. Add 5. We get 10k equals 10. Divide by 10, and k equals 1. Okay? Oh, that's a lot of k's, huh? So, yeah, okay, that's kind of how we take a look at these. We try to simplify as best as possible and just get down to one variable equaling that number, okay? So again, first step here, let's simplify by doing distribution. Now, a -8 means we take that as a -8. So -8 times -5 is going to be a positive 40r. -8 times -7, positive 56, equals 200. So I could start by subtracting 56 from both sides, which would give me 144 equals -4r plus 40r. -4 plus 40 would give us positive 36r equals 144. Divide by 36, and I believe r equals 4. Yep. Okay. So we just take a look at it, find the simplest thing that's happening, okay, and deal with it a piece at a time. So these are all these little pieces from previous ones stacked up to make 1. So -6 times 1, -6. -6 times -7, positive 42k plus 7. -6 positive 7 would be a positive 1. And I could have subtracted, or not subtracted, 42k because it's the only one on that left side, isn't it? Okay. Subtract 1. 42k equals -334. Nope, 36. So then we just divide by 42. And we get k equals, why are there so many k's? Because I like to say k when I'm done with stuff. And now I have k and then another k. And you tired of my k's yet? That ends up being -8. Okay. So we just keep trucking along here, don't we? So we multiply here by 8, giving us 16x minus 8 equals 16 plus 8x. So add an 8 to both sides, giving us 24 plus 8k equals 16x. Subtract an 8x. Well, now I'm even adding more k's in there. My goodness, I think I've done too many problems, haven't I? Divide by 8. We get 3 equals x. Okay. 36. Now, when there's just a negative, it's like a -1. So basically, it just changes everything to a negative, or if it's already a negative, to a positive. Okay, I could add 1 to both sides, giving us -3n equals -6n plus 15. And I'm just showing you all these different ways that you can start, just so that you see that there's not one way to do this. Okay. So we would add a 6n. There we go. Got a little confused there for a second. 3n equals 15. Divide by 3. N equals 5. All right, now these are the last two problems. And yes, they're more complex, but we treat them each separately. So we've got a distributive property and a distributive property. -2 times 6 is -12v. -2 times 8 is a negative. You can put plus negative or just minus, same thing. -16 minus 7 times 4 is 28. -7 times -2v would be plus a 14v equals -54. So I want to get all my numbers on the same side. So I could take them and combine them since they're on the same side. I don't have to add or subtract. I just go -16 minus 28. And I could say that that's a -44. And I could add a 44 to both sides if I really wanted to, giving us a -10. Or I could have done it a piece at a time. I could have added 16 first and then added 28 second to that 54. And ended up with, when I added 16, a -38. Then when I added a 28, a negative 10, okay? Equals negative 12v plus 14v. A negative 12, a positive 14, leaves me with two positives left over. So negative 10 equals 2v, divide by 2, and negative 5 equals v. Okay, so you just follow through, do it a piece at a time. 4 times 1 is 4, 4 times 4v, 16v minus 2 equals negative 7 times negative 4, positive 28v. Negative 7 and negative 2 is a positive 14. So I could add a 2 to both sides, giving us 16 plus 28v equals 4 plus 16v, then subtract a 4, giving me the 16v equals 28v plus a 12. Okay, or I could have combined those and got positive 2, which I would have subtracted to get 12. Subtract a 28v, and we get what? A negative 12v equals positive 12 divided by negative 12, and v is going to give us a negative 1. Okay, so there we go with our solving equations. So we go from simple to complex. We're using the same steps over and over. Hopefully seeing a lot of this helped you guys, that you will be good to go here. Okay.